So for a scatter plot, and we're going to draw a scatter plot, you're going to have to draw your set of axes, write a title and unit. So this is where things are nicely labeled. Decide on an appropriate scale for each axis. So if every mark on your grid paper is going to be 10, you have to keep that constant all the way through. If you're going to be skipping a bunch of data because your data goes from 100 to 150, then you put one of those little squiggle marks at the beginning. Label everything. Dependent goes on the vertical axis, your independent on your horizontal axis. Make a nice title. Maybe my ages one wasn't as nice for the first one. And then plot everything. Now if you're given data in a table, whatever is in the first column or the first row, the top row or the first column, that's always your independent variable, which goes on your x-axis. Once you draw your scatter diagram, you can tell whether something has a strong correlation or a weak correlation. So here are some positive correlations, but you can see that this one's much tighter to the line of best fit than the second one or the third one is. And same thing for these negative ones. You've got some data that's much tighter, so it has a strong negative correlation, as opposed to the last one, which is more spread out. As it approaches zero correlation, then it gets weaker and weaker. And you're not always getting something that makes a line of best fit. Sometimes we would still say this is a line of best fit, but this one seems to fit this curve, and this one seems to fit a line. So sometimes you plot data and you're like, oh, this data seems to be growing exponentially. And from that, you can determine, I think it's not a straight line of best fit, but maybe a different equation would fit that. For example, they were plotting the Ebola outbreaks, and they were noticing it was doing this, making somewhat of an exponential curve, which was really concerning. Because if there was 5 outbreaks today, 10 the next day, then 20, then 40, soon it could go out of control. So that's why it was such a crazy, crazy thing. So here's some data. Pick a scale for your graph. There's a graph paper there. Actually, you can check what I did here as my scale. If you want to figure out a different one, notice that I put some squiggles in there. It does not make sense to start at year 0 and then figure out where year 2009 is going to start or 2004 is going to start. Plot your data and then determine what kind of correlation there is, and that's where we're going to end for today. I don't know if you've had a chance to plot it all already. This is what it looks like. It's not looking good. Getting less and less rainfall every year. What kind of correlation would we say this is? Negative. Weak, strong, or moderate? That's pretty strong. It is pretty tight if you think about what your line of best fit would be. And from this data, if you did a line of best fit, you could extrapolate that in the future, they're going to eventually get 0 rain, and then it will go into the negatives, so there'll be like water drops flying up to the sky eventually. You know, no negative rain. Negative rain would be cool. If all of a sudden you're like, the rain is going up, so like the top of your head stays dry, but like your feet, the bottom of your feet, and your pant legs on the inside are really getting wet. It's not that fun. Oh, I should stop recording. Okay.